Hello students, let's see the revision of chapter number 2, polynomials. As we know, the division algorithm from the chapter number 2, polynomials, is cut out, so that we can't discuss here. See the first one. Find the zeros of polynomial p of x is equals to x square minus 24x plus 143 and find the relationship between the zeros and the coefficient. First of all, write the given polynomial. Given polynomial p of x is equals to x square minus 24x plus 143, in which a is equals to 1, b is equals to minus 24 and c is equals to 143. To find the zeros, take p of x is equals to 0. Now the p of x is x square minus 24x plus 143 is equals to 0. That's why instead of x square as it is, find the factors of 143 whose multiplication is 143 and addition is 24 by 11. 11 ones are 11 and 11 threes are 33. 11 plus 13 is equals to 24. Minus 13x minus 11x plus 143 is equals to 0. Pair of first two term and the pair of last two term. Now x is common, remaining into bracket x minus 13 minus 11 is common, remaining into bracket x minus 13 is equals to 0. Into first bracket x minus 13, in another bracket x minus 11 is equals to 0. Now we compare both brackets with 0. X minus 13 is equals to 0 or x minus 11 is equals to 0. That's why one time x is 13 and another x is equals to 11. Here 13 and 11 are the zeros of given polynomial. Here 13 and 11 are zeros of given polynomial. Now we find the relationship between the zeros and the coefficient. The first relationship is sum of zeros is equals to alpha plus beta, where alpha is 13 and beta is 11. 13 plus 11, which is 24. Here the b is minus 24, that's why we multiply 24 with 2 time minus upon 1. Now 24 is a minus as it is. Instead of 24 is b. Minus of minus 24 upon 1 minus b, and instead of 1 is equals to a. Minus 24 is b and 1 is a. Minus, we know the b is the coefficient of x upon a is the coefficient of x square. Here the first relationship is completed. Now second is product of zeros. Is equals to alpha into beta, where alpha is 13 and beta is 11. 13 and 11, the multiplication of 13 and 11, which is 143, nothing in denominator, then it is 1, is equals to c upon a, where c is 143 and a is equals to 1. Now c is the constant term upon a is coefficient of x square. Here both the relationships are completed. Now we see the next second number. verify that 1, 2, 3 upon 2 are zeros of the polynomial p of x is equals to 2x cube minus 9x square plus 13x minus 6. Then verify the relationship between zeros and the coefficient. First write the given polynomial p of x is equals to 2x cube minus 9x square plus 13x minus 6. Here a is equals to 2, b is equals to minus 9, c is equals to 13 and d is equals to minus 6. First we verify that 1, 2, 3 upon 2 are the zeros of given polynomial or not. The first of all, take p of 1. P of 1 is equals to 2. Instead of x is cube of 1 minus 9. Instead of x is 1 square plus 13. Instead of x is 1 minus 6. 2 cube of 1 is 1 minus 9. Instead of square of 1, 1 plus 13 minus 6. 2 ones are 2 minus 9 plus 13 minus 6. 13 plus 2 which is 15 and the minus 15 which is 0. Here the value of p of 1, value at 1 of the given polynomial is 0. That's why 1 is the 0 of given polynomial. Now we check for another number 2. P of 2 is equals to 2. Instead of x is 2 cube minus 9. Instead of x is 2 square plus 13. Instead of x is 2 minus 6. 2 cube is equals to 8 minus 9. 2 square is 4 plus 26 minus 6. 8 2s are 16 minus 36 plus 20. 26 minus 6 which is 20. 20 plus 16 which is 36 minus 36 and hence again p of 2 is also 0. Here p of 2 is equals to 0. That's why 2 is the 0 of given cubic polynomial. Now we check for 3 upon 2. P of 3 upon 2 is equals to 2 as it is. Instead of x 3 upon 2 cube minus 9. Instead of x 3 upon 2 square plus 13 instead of x 3 upon 2 and last is minus 6 is equals to 2. 3 cube is equals to 27 upon 2 cube is 8 minus 9. 3 square is a 9 upon 4 plus 13 3s are 39 upon 2 minus 6 is equals to cut is possible by 4. 27 upon 4 minus 9 9s are 81 upon 4 plus 39 upon 2 minus 6. Now we have to take LCM to solve this term. Upon 4 27 minus 81 plus 39 2s are 78 minus 6 4s are 24. Now we have to add 78 and 27. 105. 81 and 24 is again 105 plus minus 105 is cut and our answer of P of 3 upon 2 is also 0. Therefore, the first number 1, second 2 and third 3 upon 2. 1, 2 and 3 upon 2 are the zeros of given polynomial. Now we have to check the relationship, verify the relationship between the zeros and the coefficient. The first is sum of zeros is equals to alpha plus beta plus gamma, where alpha is 1, beta is 2 and gamma is 3 upon 2. 1 plus 2 plus 3 upon 2. By taking LCM, the LCM is 2. 2 ones are 2 plus 2 twos are 4 plus 3 is equals to 4, 5, 6, 7, 8, 9, upon 2. Here the 9 is b, but it is a minus b. That's why we multiply it by 2 times as a minus. Minus of minus 9 upon 2 is equals to minus. Instead of minus 9 is b and instead of 2 is equals to a, where the b is the coefficient of x square and 2 means a is the coefficient of x cube. Coefficient of x square upon coefficient of x cube. Here the first relationship is verified. Now second is sum of the product of zeros taken 2 at a time, means that alpha beta plus beta gamma plus gamma alpha is equals to 1 multiply with 2 plus 2 multiply with 3 upon 2 plus 3 upon 2 multiply with 1. 2 ones are 2 plus 6 upon 2 plus 3 upon 2 is equals to 2 as it is 4 plus 6 plus 3. 4 plus 6 plus 3 is equals to 13 upon 2 is equals to, the 13 is C and 2 is A. C upon A, where C is the coefficient of x and A is coefficient of x cube. Hence here the second relationship is verified. Now third is product of zeros. Alpha, beta, gamma is equals to, alpha is 1, beta is 2 and gamma is 3 upon 2, which is 6 upon 2, where the 6 is multiplied with minus, so that we multiply it by minus as a 2 times. Minus of minus 6 upon 2, minus as it is, instead of minus 6 which is D and instead of 2 which is A, where the minus as it is, D is the constant term and A is coefficient of x square. Now we go for a third number. Third number is also somewhat important. Root 3 upon 2 and minus 4 are respectively the sum and product of zeros of quadratic polynomial. Find the quadratic polynomial. As we know the standard form of quadratic polynomial, alpha and beta are the zeros of quadratic polynomial. P of x is equals to ax square plus bx plus c. In the question, the sum of zeros and the product of zeros is given. Sum of zeros alpha plus beta is equals to root 3 upon 2 and product of zeros alpha into beta, which is minus 4. The first of all, both denominators are not equal, then make it equal. Multiply it by 2 and divide it by 2. As we know, the alpha plus beta is equals to minus b upon a. That's why we multiply it by 2 times minus. Minus of minus root 3 upon 2. It is look like as a minus b upon a and alpha into beta, which is minus 8 upon 2, which is c upon a. Hence here the value of a, b and c is obtained. Here a is equals to 2, b is equals to minus root 3 and c is equals to minus 8. Required quadratic polynomial p of x is equals to ax square plus bx plus c, where a is equals to 2x square, instead of b is minus root 3x plus c is minus 8. 2x square minus root 3x minus 8 is our required polynomial, but in general there are infinite many polynomials are possible. Therefore k into bracket 2x square minus root 3x minus 8 is required quadratic polynomial where k does not equals to 0. Hence, the three numbers are completed. Now we see the next fourth number. Let's see the another number, fourth number. Alpha and beta are zeros of p of x is equals to 3x square minus 14x plus 15. Then find alpha square plus beta square. The given polynomial is p of x is equals to 3x square minus 14x plus 15. From that a is equals to 3, b is equals to minus 14 and c is equals to 15. Now we want to find alpha square plus beta square. For that, alpha square plus beta square is equals to alpha plus beta whole square minus alpha into beta. From the alpha plus beta whole square, alpha square plus 2 alpha beta plus beta square. By making alpha square plus beta square as a subject, we get alpha plus beta whole square minus 2 alpha beta. To find the value of alpha square plus beta square, we want to find first alpha plus beta and alpha into beta. The alpha plus beta is equals to minus b upon a, minus instead of b is minus 14 and instead of a is 3. Our answer is 14 upon 3. Now alpha into beta is equals to c upon a, where c is equals to 15 and a is equals to the 3. Now alpha square plus beta square is equals to alpha plus beta whole square minus 2 alpha beta. Alpha plus beta whole square is a 14 upon 3 whole square minus 2 alpha into beta, which is 15 upon 3. Square of 14, 196 upon 9 minus 30 upon 3. Now 9 is the LCM. 196 minus 3 3s are 90 is equals to 106 upon 9 is the value of alpha square plus beta square. Now the fifth number, for what value of k? 7 is the 0 of x square minus 5k minus 18 into x minus 35. Also find the other 0. Here 7 is 0 of p of x is equals to x square minus 5k minus 18 into x minus 35. P of 7 is equals to 0 square of 7 minus 5k minus 18 instead of x is 7 minus 35 is equals to 0. By taking 7 as a common, 7 minus 5k minus 18 minus 7 5s is equals to 0. 7 minus 5, which is 2, opening bracket, minus 5k minus minus plus 18 is equals to 0. 18 plus 2, which is 20, minus 5k is equals to 0. That's why 5k is equals to 20 and the value of k is 20 upon 5. 5 4s are 20. That's why k is equals to 4. The value of k is 4 is obtained here. Now, to find the other 0, we substitute this value of k in the polynomial. P of x is equals to x square minus 5k minus 18 into x minus 35. P of x is equals to x square minus 5, instead of k is 4, minus 18 into x minus 35. X square minus 5 4s are 20 minus 18 means minus 2x minus 35. To find zeros, take P of x is equals to 0, where P of x is x square minus 2x minus 35 is equals to 0. That's why x square, the factors of 35, minus 7x plus 5x minus 35 is equals to 0. Pair of first two term and the pair of last two term. Now x is common, into bracket x minus 7 plus 5 into bracket x minus 7 is equals to 0. Into first bracket x minus 7, in another bracket x plus 5 is equals to 0. On comparing both bracket with 0, we get 1 time x minus 7 is equals to 0 or x plus 5 is equals to 0. That's why x is 7 and the second time x is minus 5. Hence 7 and minus 5 are zeros of given polynomial. Now sixth number. For what value of a minus 3 is 0 of P of x is equals to x cube plus 12x square plus ax plus 60. Minus 3 is 0 of P of x is equals to x cube plus 12x square plus ax plus 60. That's why P of minus 3 is equals to minus 3 cube minus, first of all we have to take minus 3 is equals to 0 because minus 3 is a 0. If you take directly, then write 0 instead of P of minus 3. Minus 3 cube plus 12 minus 3 square plus a, instead of x minus 3 plus 60 is equals to 0. Cube of minus 3 minus 27 plus 12 into minus 9 minus 3a plus 60 is equals to 0. Minus 27, 12 9s are 108, but it is minus 108 minus 3a plus 60 is equals to 0. Minus 27 and minus 108, 115 plus 60 minus 3a is equals to 0. Minus 115 plus 60 it is not 115, it is a 135. 135 minus 135 plus 60, which is 5, which is 7, minus 3a is equals to 0. That's why a is equals to 75, but it is minus 75. Therefore, a is equals to minus 75 upon 3, and our answer of a is minus 25. The value of a is minus 25 whenever the minus 3 is 0 of the given polynomial. Now the next, seventh number. If the sum of zeros of P of x is equals to a minus 1 x square plus 2a minus 6x plus 3a minus 18 is minus 1. Then the product of 0, find the product of 0. First of all, the polynomial is given. P of x is equals to a minus 1 into x square plus 2a minus 6 into x plus 3a minus 18. Here the coefficients are in small a, that's why the capital A coefficient of x square a minus 1, capital B 2a minus 6, and the constant term c is 3a minus 18. Now first of all, the sum of zeros is given. Alpha plus beta is equals to minus b upon a, where alpha plus beta is equals to, the sum is given minus 1 minus, instead of b is equals to 2a minus 6 but into bracket upon a is equals to a minus 1. Minus minus cut here, a minus 1 is equals to 2a minus 6. A goes to left to right and minus 6 right to left. 6 minus 1 is equals to 2a minus a. 2a minus a is equals to a. 6 minus 1 is equals to 5. Here a is 5. The value of a is 5. Now we find the product of zeros. Product of zeros is equals to alpha into beta where alpha into beta, as we know, c upon a, where c is equals to 3a minus 18 upon a is equals to a minus 1. Now we substitute the value of a is 5 minus 18 and 5 minus 1. 5 3s are 15 minus a upon 4, which is 15 minus 8, 7 upon 4. Hence, the product of zeros is minus 7 is the 18 minus 3 upon 4. Minus 3 upon 4 is the product of zeros for the required polynomial. Now we see the next one. Sum and product of zeros of p of x is equals to x square plus k minus 7x plus k plus 1 are equal, then find k. Given polynomial p of x is equals to x square plus k minus 7 into x plus k plus 1. Here the sum and product of zeros are equal. Sum is alpha plus beta and product is alpha into beta. The sum alpha plus beta, as we know, minus b upon a, and product alpha into beta c upon a, where a both are cut. Minus, instead of b, a is equals to 1, b is equals to k minus 7 and c is equals to k plus 1. Minus b is k minus 7 but put it into bracket and c is equals to k plus 1. First we multiply minus with bracket, minus k plus 7 is equals to k plus 1. Now minus k goes to left to right and 1 right to left. 7 minus 1 is equals to k plus k. K plus k, which is 2k, equals to 7. Therefore k is 6 upon 2. 2 3s are, the value of k is 3 whenever the sum and the product of zeros of the given polynomial are equal. Now see the ninth number. Alpha, beta and gamma are zeros of p of x is equals to ax cube plus bx square plus cx plus d. Find 1 upon alpha plus 1 upon alpha beta plus 1 upon beta gamma plus 1 upon alpha gamma. Second, 1 upon alpha plus 1 upon beta and 1 upon gamma. First is 1 upon alpha beta plus 1 upon beta gamma plus 1 upon gamma alpha. By taking LCM, our LCM is alpha, beta, gamma. Instead of 1 is gamma, instead of second one is alpha and instead of third one is beta. Now alpha plus beta plus gamma is the sum of zeros minus b upon a, and alpha into beta into gamma is the product of zeros for the cubic polynomial, which is minus d upon a. Now minus minus cut, a cut, and we get b upon d. The b upon d is the value of 1 upon alpha beta plus 1 upon beta gamma plus 1 upon gamma alpha is equals to b upon d. Now second, 1 upon alpha plus 1 upon beta plus 1 upon gamma. Again we have to take LCM. Alpha, beta and gamma is the LCM. Instead of 1 is equals to beta gamma, instead of second one is equals to alpha gamma, and instead of third one is alpha beta. As we know, the alpha beta plus beta gamma plus gamma alpha is the sum of the product of zeros taken two at a time is equals to c upon a, and alpha into beta into gamma minus d upon a cut, and we get minus c upon d is the answer of 1 upon alpha plus 1 upon beta plus 1 upon gamma. 1 upon alpha plus 1 upon beta plus 1 upon gamma is equals to minus c upon d. Hence, the revision of chapter number 2 polynomial is completed. If you have any query regarding the chapter number 2 or regarding our homework, please tick mark it very well. Whenever we meet each other, we can solve it easily. When we meet in next session, we discuss the revision of another chapter.